So in this example, we have this customer satisfaction, and it says Happy Flowers Floral Delivery Company states that it has a 95% customer satisfaction rate on the delivery of its flowers. And then we have these two questions here, A and B. I'll just put A right here. And it says if someone has flowers sent to their date from Happy Flowers, what is the probability that the date will not be satisfied? So if there's a 95% customer satisfaction rate, then the probability somebody will not be satisfied, well, that'll be 1 minus the 95. And of course, that comes out to be 5%. For B, it states if 10 random people send flowers from Happy Flowers to their dates, what is the probability at least one of the dates will not be satisfied? So here we have this term again, at least one. So what does that mean? Well, 1 or 2, or it could be 3 or 4, or maybe all 10 are not satisfied. So if I was to make the sample space that represented B, maybe it would look something like this. If I let Y mean yes, they're satisfied, and N mean no, they're not satisfied, maybe it could look something like this. So here we have these 10 people. This first person said, yes, I'm satisfied. The second person says, yes, I'm satisfied. The third says yes, and all 10 say yes. Another possible outcome could look like this. So where the first 9 all say they're satisfied, but then the last person says, no, I'm not satisfied. So here's at least one. Or another possible outcome could be this. So here the first 8 say yes, the 9th person says no, and then the last person says yes. Or maybe one of the outcomes could look like this. Where the 8th person says no, and the last 2 say yes. So if I was to continue on with this pattern, maybe the sample space would probably end up with everybody being not satisfied. And as you can see here, this group right here, this group represents at least one. There's at least one here, at least one here, at least one here. And if that pattern continues, and believe it or not, there's over 1,000 different outcomes. By the time we get to the end of the pattern, nobody is satisfied. So we would have to determine the probability for each one of these outcomes in order to determine at least one. Well, rather than do that, let's do this outcome up here. This is the complement. So where it says at least one date will not be satisfied, the complement to that is where everybody is satisfied. So that's this here. So what's the probability that this individual, when they're asked, are you satisfied? There's a 95% probability that this person will say, yeah, I'm satisfied. There's a 95% chance that this one will also say, I'm satisfied. And the same with the third person and the fourth person. So if this person is satisfied, and this person is satisfied, and this person is satisfied, and they're all satisfied, then what's the probability that they'll all be satisfied? Well, if there's so many ways of one thing to occur and so many ways for another thing to occur, according to the fundamental counting principle, we simply multiply. So if I multiply 95%, 95%, 95%, that can be written as 0.95 to the 10th power, or 0.95 multiplied to itself 10 times. But this is the probability that everybody's satisfied. For at least one to not be satisfied, that's this group here, we just subtract 1 minus 0.95 to the 10th power. And 1 minus 0.95 to the 10th power, that comes out to be approximately 0.4013. And of course, we recognize that is 40.13%. So the idea is once we see this at least 1, it could also say at least 2, but if we have at least 1, that means there's got to be more than just 1 that we would have to tabulate. So in order to ease our work here, find its complement, and chances are its complement will only have 1 or 2 possible probabilities to determine. And there we go.